Hello students, today we are going to solve this sum from chapter kinetics, and this sum is related to order of reaction. I will be showing you two ways to solve this sum. There are two ways, one normal way and the second is alternate way. So I will show you both the ways. So let's start. So here they have given a table below shows kinetic data for the following reaction. C+D forms E+F. So they have conducted three experiments, and concentration of C in mole per dm cube is given and D in mole per dm cube is given, and then initial rate also is given in mole per dm cube per minute. So let's find what they have asked. So first thing what they have asked is deduce the order of reaction with respect to both C and D, giving the reason for each case. So let's solve this. So here first of all we need to convert everything into it is given in scientific notation like 2.0 into 10 raised to minus 3. So it's always desirable to convert it into decimal, so it becomes easy to make out. So like it is 2.0 into 10 raised to minus 3. So we can write this as 0.002. So this can be written as 0.002. So here I will write. So here 2.0 divided by 1000 divided by 1000 will become 0.002. So this I will write here. Instead of this, it's better to write like this. So here I will write this value as 0.002, and I will calculate for each and every one of these from scientific notation to decimal form. So let me calculate. So I have converted everything from scientific notation to decimal form. Now let's consider experiment 1 and experiment 2. This experiment 1 and experiment 2. As you can see in experiment 1 and experiment 2, there is change in the concentration of C. The C is 0.002 and it has become 0.004. So there is a change, and D is remaining constant 0.003 and 0.003. So we want to find for C. So it's always desirable to find for the concentration. It is always recommended, so that you should where the concentration changes and the other concentration should be constant. So this D is constant here 0.003 and 0.003. So this we will not consider here. We will only consider with respect to C and what is happening to the rate. So as you can see here, with respect to C, 0.002 and 0.004. So it is becoming what? It is becoming twice. How it is becoming twice? We can solve also. So experiment 2 divided by experiment 1 we can do. So experiment 2 we got the value as 0.004. This value I have taken and divided by 0.002. So 0.002. This is easy. So but there are difficult sums, so that's why I am showing the way to solve. So you will get the answer as 2 because 2 2s are 4. So this we got. The concentration is doubling here in case of experiment 1 and 2. So this way we can do. Okay. Now here rate also we will find for this one. So rate, let's see the rate. So here 0.0001 divided by 0.0002. So for rate I will choose pink color. So let's divide 0.1 2 3 4 5 0 1. Here 2 because this one we have to take in the numerator and lowest in the denominator. So this value we will take in the denominator 0.1 2 3 4 5 and 1. So here also you will get the answer as 2. So as you can see the rate is doubling, concentration doubles. Here concentration is becoming 2 times, so rate also becomes twice. So that's why it is first order reaction. So we can make out just by looking also, because this value is there and this value is there. So you divide these two values 2 upon 2, so you will get the answer as 2. But it's better to remember one table. So that table I will explain you that table. So here is the table. For zero order, when concentration is doubling, there is no change, no triples also no change and no change. So this is very easy for zero order. But for first and second order, that rules you should memorize. So you can easily directly looking upon the table you can make out. So first make out for when concentration is doubling for first order. So rate also doubles. Rate becomes double. Here rate becomes double. And if rate here concentration triples, then rate also triples. Same thing. What is happening here? How much is the concentration? Same will be the change in the rate for the first order. and here also if it becomes quadruple or becomes 4 times, so it also becomes quadruple or becomes 4 times. So for first order it is as it is, like concentration doubles, so first order rate also doubles. If concentration triples, so first order rate also triples, and if it quadruples, concentration quadruples, so rate for the first order also quadruples, means becomes 4 times. So now for second order, so let's check for second order, if rate doubles, the for second order, if concentration doubles, the rate becomes 4 times. Rate becomes what? 4 times. Rate becomes 4 times. Okay, so remember this. And if concentration triples, so rate becomes 9 times. Remember this. Rate becomes 9 times. And if it increases, if concentration quadruples, it becomes 4 times. So rate becomes 16 times. So this table, when you are able to recollect, then it will be easy for you to solve. Otherwise, we can solve by other ways also, that I will explain you. So let's see for the previous sum what we were doing for the previous sum. So in this sum, as you can see, the concentration, this is for concentration of C, as we are doing for C. So concentration of C was 2, and then rate also became, here increase in rate also became 2. So both the values are 2. So we can see it is same it is. So here we can go back and see. So here you can see concentration doubles, it was 2, and here also rate also doubled. So it is actually, the order is our first order reaction. So that's why we can write this reaction, previous reaction, as first order with respect to C. So first order with respect to C is written how? So it is written in like this, you have to write, and you have to write on this. You have to write like this, upon 1. Now we have done with respect to C. Now we will do with respect to D. So let's check with respect to D. So now we will look for with respect to D. So we have to choose a value where D is doubling, or D is becoming tripling, or D is becoming quadrupling. So that we will choose. In experiment 1 and 2, here you can see D is remaining 0.03 and 0.003, and here also 0.003. So it is not affecting, means the concentration is not doubling at all. So we will not consider experiment 1 and 2. Instead we will consider our this experiment 2 and 3. Why? Because here you can see it is changing. D should change. What we are checking should change. Now C we have already done, so we will check out. We will cross C. So we will not take C. Now we will just talk about D. So here 0.03 is becoming 0.06. So we will take this value and we will find out. So as you can see, 0.06 divided by this value I have taken, divided by 0.003. Okay, so then it is becoming 3 2s are 6. It is becoming doubling. That means concentration is doubling here. The concentration is doubling 2 times. Concentration is doubling. Concentration of D is doubling. Okay, 2 times it is becoming. As you can see, but we can see here. So let's see. So let's see about the rate. Now rate, we can see this value and this value we will divide. So this bigger value we will take in the numerator. So 0.00003 divided by 0.00002. So it will be coming to 1.5. So it is coming in decimal. So this cannot be considered. It should be either doubled or triple or quadrupled. It should be a whole number. So here that means doubling D does not have any effect. As you can see, we will refer our table. So you can see this doubling does not have any effect. No, you can see no change in the rate. So we can say there is no change in the rate. So with respect to D, we can write there is no change in the rate. So with respect to D, no change. With respect to D, there is no change at all. So this is one way to solve this sum. We can solve by other way also, other method, using indices. For that you should be actually well versed with indices, the mathematics topic which you have done in your lower classes. So let's do by the other way also. But alternate method is formula method. So we have to just remember one formula, and that formula is very simple. So that formula we need to always take that formula. So concentration of C, we can assume it as A, means we will take in other formula. So we can assume this row as A and this row as B and rate row as R. So you can see we can then consider experiment 1 as A1, experiment 2 as A2, and then this rate 1 and rate 2, this we can consider this as rate 1 and rate 2. So the formula, how the formula is, so let's I will explain you. The formula is like this: R1 upon R2 is equals to A1 upon A2 raised to M into B1 upon B2, B1 upon B2, then raised to M. This is the formula. If you remember this formula, then we have to just substitute the values and get the answer. So let's substitute and find the answer for this one. Rate 1 upon rate 2. So this I will write here, rate 1 upon rate 2 as 1.0 into 10 raised to minus 6. This value I will write here, rate 1. Then rate 2 is 2.0 into 10 raised to minus 6 upon 2.0 into 10 raised to minus 6. 2.0 into 10 raised to minus 6. So this we have written here, R1 upon R2. So is equals to, then A1 upon A2. This upon this. So this is A1 and this is A2. So 2.0 into 10 raised to minus 3 upon this value 4.0 into 10 raised to minus 3. So we will close the bracket like this, and we will put here M, then into, then this part we will substitute this part now. So B1 upon B2. What is B1? B1 is this value. So this, right, we can write 3.0 into 10 raised to minus 3, and B2 is this value. So this we can write as 3.0 into 10 raised to minus 3. So just we have substituted everything in this formula. We will write the formula on the next page, and we will solve this equation to find the value of M and N. So raised to N here, M raised to N. So let's find, so let's check it. So here it is raised to power to the N, and here this is power to the N, and this is power to the N. So let's write this formula. So let's solve. So as you can see here, this 10 minus 6 will go, 10 minus 6 will go. Then here 10, this is 10 minus 3 will go, 10 minus 3 will go. And here also 10 minus 3 will go and 10 minus 3 will go. There is a mistake actually. While copying this, I could not copy properly. So here, as you can see, this value, this I will copy here. It is 3 upon 3. So it should be 3 upon 3. And so I will recopy it, and we will solve this. So cancel this, and I will resolve this. Here I have exactly copied what we have done here. Previously same I have copied this value, this whole thing I have copied as it is. So let's solve this now. So as you can see here, this will go, 10 minus 6 and 10 minus 6 will go. Then even this 10 minus 3 and 10 minus 3 will go, and this will become 2 1s are 2, 2 2s are 4, and this whole thing will go, because 3 into 10 minus 3 it is there, and this bottom also 3 into 10 minus 3 is there. So it will become now 1 upon 2, this has become 1 upon 2, so equal to, then this equals to 1 upon 2, this M is still there, so raised to M, and then into, because this whole thing has gone, so here this n will also, because 1 raised to n is equals to anything raised to n will become here 1, this will become, so it will become 1, this will become 1. So now let's solve this equation and we will get the value of m. So we can do on the next page. So m will become 1. So this is first order with respect to C. As we got the value of m, that is 1. So we got the value of m as 1. So it is first order with respect to C. So in this way we can do for this also. B part means our concentration of D. So let's do. Take experiment 1 and 3 to find change in D. So let's do this. So we will use that same formula what we have done previously, this formula. So just we will substitute the values here in this formula. So this is the formula. Now because we are taking experiment 2, we are taking experiment 1 and 3. So this we will make it as 3, R as 3, and this A2 as A3 and B2 as B3. So we will substitute all the values like this and we will get the answer. So rate 1 upon rate 3. So rate 1 upon rate 3 means 1.0 into 10 raised to minus 6 upon 3.0 into 10 raised to minus 6. So this we will rate 1 upon rate 3, 1.0 into 10 raised to minus 6 upon 1.0 into 10 raised to, so 3.0 into 10 raised to minus 6. So this, now this 2.0 into 10 raised to minus 3 divided by 6.0 into 10 raised to minus 3. So 2.0 into 10 raised to minus 3 upon 6.0 into 10 raised to minus 3. And then for D also same way we will write here this upon this, so into, and this raised to also, as we got the value of m as 1, so we will raise to, instead of m we will write here as 1, okay, raised to m. Now here into this value, so here into, now the this we will make for our D value. So here we will write 3.0 into 10 raised to minus 3 upon 6.0 into 10 raised to minus 3. Now we will close the box like this, and raised to, here also it is raised to n. So we will write here raised to n. I will write with black color. So this is raised to n. So we will solve this. When we will solve this, now we will get the answer. So here as you can see here, this value will go, and this value will also go, and 2 1s are 2, 2 3s are 6 it will become, and this value will also go, and 3 1s are 3, 3 2s are 6 it will become. So the it will form equation like this. Equation will be one upon 3 equals to 1 upon 3 into 1 upon 2 raised to n. So rule of indices, it will, now this 1 upon 3 and 1 upon 3 will go. So here it will become 1 upon 2 raised to n equals to 1. So n will become 0, because the rule says 1 upon 2, whenever it is like this, so n will become 0. The indices will become 0. So indices rule says that. So that's why we will get the value with respect to D as 0. So in this way we can solve by this method also. In the second part they have asked deduce the rate expression for this equation. So for rate expression we can just do rate is equals to, then we can write here constant because it is directly proportional to, so here you have to put K. With respect to C, we got 1, so we will write raised to 1, and with respect to D we got 0, so we will write here 0. Now use the experimental data, use data from experiment 1 to calculate the value of rate constant from this reaction and deduce its unit. So we can do this part also. So here we will write the same equation, rate equals to K, then c with respect to 1. So c with respect to 1, this wherever 1 is there, we should not write also, it depends on us. And d equals to 0, so d is eliminated. So this is the rate equation we got. Now rate equation, when we get it, so we have to just find k. So we can rearrange this equation. K equals to rate upon c, concentration of c, change in c. So this is the our equation for this k. So now we can find the value of k by substituting the values here. Always actually be careful, you have to take from the same experiment, okay, all this value. Rate, suppose I am taking from experiment 1 this rate, and then I will take for this value, this also concentration value from experiment 1 only. So we will see. So rate, now here as you can see, so I will take the value from here. So this is the value of rate and this is the value of c. So we will take these two values, okay, and we will, now this was this divided by that. So I will write the equation here only. So k equals to rate upon c. So rate equals to 1.0 into 10 raised to minus 6 upon, then value of c from experiment 1 also I am taking both the values. So 2.0 into 10 raised to minus 3. So we will solve this, and we will get the answer as on the calculator as 5 into 10 raised to minus 4. Okay. Then inverse of minute, as unit is given in minute, so inverse of minute. So here we got this value of k. So this is the rate constant. If we are see, if you are solving and you want to take the this data from experiment 2, we can take from experiment 2. Then this value 4.0 into 10 raised to rate, we can take from this 2.0 into 10 raised to minus 6. We can do in this way also. K equals to rate upon c, rate upon c, we can do in this way. So here we will take from experiment 2. So we will substitute the values here. 2.0 into 10 raised to minus 6. Okay, this value we will take minus 6, and then upon 4.0 into 10 raised to minus 3. To minus 3. So we will when you will solve now, you will get the same answer. Okay, so but you have to take from the same row. If you are taking experiment 2, then this value and this value, as d is it is not affecting d, so d is raised to 0, so d you will not consider. And if I have taken the initially I have taken this one, so that's why we have taken the rate value from here and this value from here. So this you should be careful, okay, not from different rows, from the same rows you have to take. Here B part they have given. So what they was, define the term half-life. So the definition is very easy. So the definition says that time taken for the reactant to become half from its original value. So that you should remember, time taken for the reactant to become half from its original value. So that is the half-life. Now they have asked another part, this portion, second portion of this question. So as you can see, they have calculated the half-life of the first order reaction. So this we need to find out now. So for this we will solve. The formula is very simple. You should remember the formula like this: T half. So this is universal formula. So this always remember, inverse 2 upon k. So this inverse 2 is having a value of 0.0693. This you should remember, 0.0693. Inverse 2 is 0.0693. So that's why this formula is like this: half equals to 0.0693 upon k. So here just we will substitute the values of this and we will get the answer. In this formula we will substitute the value and we will get the answer. So T half. So just we have to substitute the value of k, what they have given, rate constant. So rate constant they have given us 3.3 into 10 raised to minus 2. So we will substitute the values here. So let's substitute the value. So t half equals to 0.0693. So we will convert this into decimal. 3.3 divided by 1, 2, 10 raised to minus 2, that means 100. So it will become 0.033. So 0.069 upon 0.033. Let's solve this. So t half equals to, so 0.069 upon 0.033. On the calculator, this all it will come to 21 minutes. So this is the half-life of this. Okay. So in this way we can find the half-life also. So thank you for watching this video. Take care. Bye.